All right, here we go. 3.4 quadratic inequalities. So remembering what inequalities are, is what we're going to focus on. But remember, understand basic concepts about quadratic inequalities, solve quadratic inequalities graphically, and solve quadratic inequalities symbolically. All right, so inequalities, equality versus inequality. Equality means that you have an equal sign involved. Does that make sense? So equality means I have an equal sign, even if it's saying that it's not equal. Inequality means that you have this guy. Okay, so we have our open, what do you call it? My third grade teacher called it an alligator because we were Andrew's alligators. And so our school, they called it the alligator, which went along with our school's theme. Did yours also call it alligators?
No. My teacher called it Pac-Man.
Ah. Oh, we called it alligator, and it worked for our school because we were Andrew's alligators. And so at Andrew Elementary in Austin, Texas, this was an alligator's mouth. Okay, and at this time, that's when you learn the alligator eats the most, right? Okay, so that's what your greater than and less than symbols were first introduced to you. Then you were to learn about greater than or equal to, greater than, less than or equal to, and then that's when things started getting different, right? So we're like, well, hold on. All right. So when we look at it graphically, how do we solve this? So if it says 1 minus x squared is less than 0, okay, that means we're looking for what? Below. We're looking for when is it below the x-axis? So when is it below y equals 0? Does that make sense? So the graph, so on our graph, we're looking at the part right here. So we're looking here. Uh-oh, that extra piece. Of course. My pen wouldn't let me be great. So we're below 0 here. And we're below 0 here. Does that make sense? And then we just write what the intervals are. So for answer for part A, when am I below 0? Well, for A, I'm below 0 when x is less than -1. Does that make sense? So when x is less than -1, I am below 0, below the x-axis. I'm also below 0 when x is greater than. I didn't mean to write that. And x is greater than 1. How do you feel about reading the graph? Simple? Do we get it? Remembering it a little bit in life, maybe? All right, so then now it says, when is x 1 minus x squared greater than 0? So if I'm greater than 0, that means I'm looking for when it's above the x-axis. Okay, right, Darren? When we're above the x-axis, we're looking for when it's greater than 0. So when we're looking at this, I was such a good student, and I thought, you know what? I'm gonna get some good karma in life.
You got a grade.
I thought I was gonna get good karma because I was such a good student, and yeah. So, all right, so now what are we above? So we're above between -1 and 1. So when x is less than 1 but greater than -1, that's when it's greater than 0. Okay, how do we feel about reading the graph? Good? Doable?
Oh, it looked like the negative one was first.
What do you mean?
Is that possible? Like if there was 1 and then -1.
No, it stays in numerical order. Yeah. Then you would be wrong. All right, so this one, notice here that it's not set to 0. So before we do anything, we want to make this 0. One side needs to be 0. So one side needs to be 0. Okay, so in order to do that, we're going to move So we're gonna do. We want to always try to keep your A positive. So we're gonna move our 5 and our -4, which means that I am subtracting 5 and adding 4x. So we have 0 is less than x squared plus 4x minus 5. So what this problem is asking us is when is this function greater than 0? Does that make sense?
Yeah.
So when is this function greater than 0? If seeing it this way bothers you, you can always do what's called the mirror. So if I was to mirror this, it would be, I can't write, x squared plus 4x minus 5 is greater than 0. Like literally, you would reflect it. Same thing, just written in another order. Does that make sense? All right, so I'm greater than 0, which means I'm looking for when I am above the x-axis. So at what point am I above the x-axis? So I'm above the x-axis here, and I'm above the x-axis here. Do we see that? So our answer is when x is less than -5, and when x is greater than 1. Okay. I also want to show you that these can be written as interval notation. So in interval notation, it would be from -infinity to -5 union 1 to infinity. So if it asks for interval notation, this is interval. And this is our inequality. Okay. All right. Questions, comments, concerns? It's not terrible, right? Okay. All right, now we're going to talk about doing it on your own using the calculator, okay? So please make sure you have a handy dandy calculator. Let me grab mine. So we have the equation 5x squared plus 14x minus 3. When it says equals 0, we want to know when does it touch the x-axis, right? When does it equal 0? So I'm going to graph this. I'm going to go to y equals, and I'm putting in 5x squared plus 14x minus 3. And then I'm going to hit graph. And on here, I can see where it crosses the x-axis. So I see that it crosses the x-axis at 0, 0, and -3, 0. If I'm not confident in what I see, I can always click second graph and look at the table. So when I look at the table, I'm like, oh, I thought it was 0, 0. It's definitely -3, 0. But was I right about 0, 0? No. What is the value at 0? -3. It wasn't 0, 0. Okay. So then we're going to have to, yes.
What's the random?
Your variable button is right next to your alpha.
Now you just click on the green button and over here, right there.
Or just click the variable button.
One,
All right. So if you look right here, we have our variable button. So graph, we looked and I was like, oh no, you're wrong. It's not 0, 0. So I'm going to zoom in to see what I see. So I'm going to zoom in. And it's like, oh, you were right. You're not at 0, 0. It's at another value. I have to find that value. So in order to find the value that it's at, we actually press second trace. And we're looking for the 0. Does that make sense? So we're pressing second trace. And we're looking for the 0. So that's going to be a 2. Okay, right now I can't see my little spider. There he is. So my spider, I need to be below the x-axis and I'm gonna crawl above the x-axis. And it's like, is this where you want me to find your 0? And I'm like, yes, I do. So my 0's actually at 0.2, 2/10.
This equation, you put equals 0.
No, you just put in 5x squared plus 14x minus 3. Okay. So on here, I can sketch that my values are at 1, 2, 3, -3. This was all the way down here at 0, 3. And then this was actually at 0.2, little dot. So I know my graph does something to the effect of it goes all the way down. Pretend that I went through that. And it comes all the way back up. And this is going to be a little wobbly. It's okay. You saw the real thing. Okay. So the equal to, so again, this is at -3 and this is at 2/10. So equal to means where do you touch the x-axis? And where do I touch the x-axis at? We touch at x equals -3 and x equals 2/10. 0.2 is not 2. Okay. What does it mean when it says less than 0? Less than 0 means below the x-axis. So when are you below the x-axis? Okay, so I'm below the x-axis between -3 and 0.2. Do we see that? So we're below when x is between -3 and 0.2. Okay, you can also write it as -3, comma, 0.2. Okay, greater than. So greater than means above the x-axis. So when am I above the x-axis? To the left of -3 and to the right of 0.2, 2/10. So when x is less than -3 and x is great, oh, whoa, whoa, whoa. No pen, don't do that. And x is greater than 2/10. I can write it again in interval notation from -infinity to -3 and from 2/10 to infinity. So this is putting it all together. Inequalities. Okay, where are you stuck at? Okay, so let's look. So we graphed it. Let me reset my graph. So when you put it in to y equals, we put in 5x squared plus 14x minus 3. Yes. Then we're going to hit graph. And we thought that it was at 0, 0. Did you just reset your calculator? That means that someone already changed your settings. Remember, I told you a good idea when you get a calculator in this class is reset. And how do we reset? Second plus 712. Second plus 712. Okay. So then once you input it into y equals 5x squared plus 14x minus 3, we're then going to go to graph and you should see your graph. Okay. I'm going to practice just, even if I didn't want to look at the table, or if I didn't want to count, pretend that I didn't know where the values were. I'm going to press second trace and I'm looking for when it's equal to 0. So I press 2. And if I just wanted to confirm on this one, it didn't want to be there. It's cool. Left bound. So when you're coming from the left, you read the graph from left to right. I'm going to go above the x-axis, hit enter. Go below the x-axis, hit enter. And it's going to say your first 0 is where? 3. -3, right? I'm going to do the same thing on the other side. Second, trace 2. On the right side, you're gonna go below the x-axis. Even if you can't see it, pay attention to your numbers. So notice that y is negative, so I know I'm below the x-axis. I'm gonna go above the x-axis. Now notice that y is positive, so I know I'm above the x-axis. Does that make sense? Press enter, hit enter, and it says your other zero is at 0.2, 2/10, which is why we marked on the graph -3 and 2/10. Okay, you can always zoom in if you want, but you don't have to zoom in for the calculator to do its job. Okay. All right. Questions, comments, concerns about graphing to find the inequality. Okay. All right. Always have to have a real world example. So here's our real world example. The quadratic inequality 1/9 x squared plus 11/3 x is less than or equal to 2,000. Gives the stopping distance for a car traveling at x miles per hour on a wet level pavement. Solve this inequality to determine safe speeds on a curve where a driver can see the road ahead for at most 200 feet. What might be a safe speed limit for this curve? Okay, so x is the miles per hour that they're driving. And so we want to know what would be the safe. So it's saying at most 200 feet. So that's why this says less than or equal to 200, because it says at most. Does that make sense? Because it could be more than 200, but not less than 200. Okay, so we have 1/9 x squared plus 11/3 x is less than or equal to 200. If the fraction bothers you, remember you can get rid of a fraction by multiplying by the least common denominator. What is the least common denominator of 9 and 3? It's 9. The greatest common factor is 3, but the least common denominator, the largest number the smallest number they both divide evenly into is 9. So I can multiply everything times 9, and that'll get rid of my fraction. So 9 times 1/9 is 1. 9 times 11 is 99. 99 divided by 3 is 33. And now we're just working with x squared plus 33x is less than or equal to 800. So that got rid of our fraction. Now, is this problem now any different than what we just did? Not really. We just got to make it to 0, right? So x squared plus 33x minus 1800 is less than or equal to 0. So we're looking for when it is what? We're less than, so we need to be where? Above or below the x-axis? Below. When are we below the x-axis? Okay, so if I graph this and I look, when is it below the x-axis? So I go to my calculator, I'm going to put in x squared plus 33x minus 1800. I'm going to hit graph, let the calculator do some thinking. And I'm like, oh no, I see nothing. Well, guess what? I need to do some zooming. So I'm going to zoom out because my numbers are kind of large. I'm going to zoom out. Oh, I see a line. I see a line. Okay. I zoomed out too far, or maybe not enough. If you also can use zoom fit. If you scroll down, you may see where it says zoom fit, and you can let the calculator say, okay, what do you think is a good look for us, calculator? And it'll show us. All right. Can you have negative speeds? No. So we know that this is going to be, our stopping point is going to be 0. Does that make sense? So we only need to know this 0 value. I'm going to go second trace 2.
You have a negative velocity though, right?
Yeah.
Yeah, because it's like direction too. And if you go back to where you started, it's negative.
So we're at 29. So between 0 and 29 miles per hour, 29.02. And again, why did we say 0 and not find the other 0, the other x-intercept? Because we're eliminating that negative speed, right? So our answer is x is between 0 and 29.2 miles per hour. So going around a curve. That's the speed. So notice how when we have y'all gone around the curve on Lakeshore Drive
Yeah.
and it says 30 miles per hour. Do you understand why it's 30 miles per hour? You have to slow it down because of how much of the feet ahead of the road you can see. That's why it's the safe speed for you.
Are you talking about
Oh my
the-
gosh.
The big road that's like really curvy,
Yeah.
that means go 60.
Oh my gosh, that does not.
That is what? 36.
All right, so we'll stop here and then tomorrow we'll finish. Thursday you'll have a quiz and
No, drop out.